All right. So for this particular example, we're going to go ahead and now move on to circles. If you guys remember, there was a standard form, the equation of the circles that I told you guys that it was derived from the Pythagorean theorem. Very similar to the distance formula. And we were able to identify the parts of the equation to a circle by finding the distance in the x direction. But now my first coordinate is x. My second coordinate, guys, my second coordinate is now labeled as h. H is going to be part of my center. And then we had our y coordinates, the difference of our y coordinates, but I now have k instead. And k is the y coordinate of my center. And we still have that distance or that c that we were having as a beautiful hypotenuse. We now have it as a radius. And we're going to go ahead and apply the Pythagorean theorem. So that's why they're all being squared. So remember that I told you guys, again, my h is my x value of my center. My k is the y value of my center. And the radius is what we have from the circle, the center of the circle, all the way to a side. So this is my radius and this is my center at h and k. Okay. All right. So from here, we're given the information that our center is at what point? What's our coordinate? Center is at -5 and 2. And we're given that the diameter of the circle has a length of 12. So my diameter is actually from side to side of my circle, including the radius. So if my diameter is 12, how much is my radius? We said that radius was half of that, so it has to be 6. So my R is 6. So all we have to do for this example is substitute our values very carefully. Make sure that you guys write everything appropriately. So we have our beautiful x value. Nothing goes into this value. Minus my x value for my center is -5. So we're going to go ahead and square it. Plus we have our y value minus we have our y value for our beautiful center, which is 2. We're going to go ahead and square it. And then we have our radius, which is 6 in this case. And we have to square it. Again, we're applying the Pythagorean theorem. A ver, let's go ahead and fix our signs. We have x minus -5. What does that do? It becomes a +5. So we have x plus 5 squared. We have y minus 2 squared. And we have 6 squared, which is beautiful 36. So which one is this one? This one happens to be beautiful C. If you guys did this problem, make sure you guys check your work. So what happens to the signs in my center? They what? They swap signs. All right, let's go ahead and move on to number 14. We're going to go ahead and write the equation of the graph circle. So for this one, let's go ahead and identify. Again, we need it in standard form. In standard form, x minus h squared plus y minus k squared equals r squared. So we need our center and we need a radius. Are we given the center? What is it? 2 and -5, and my radius 3. So let's go ahead and do the same that we did previously. We're going to go ahead and substitute our values. We have x minus 2. Remember, this is a h. This is a k. Y minus, we have -5 squared equals 3 squared. Don't forget to square your beautiful radius. Some of you guys forget. So don't forget. It's part of the equation. We have x minus 2 squared. This is already simplified. Negative and negative give me a +5. So it's going to be now +5. Squared equals 3 squared is beautiful 9. So which one is this one? It is beautifully A. And again, we're looking at our parts. We're going to go ahead and make sure that we identify our h and k, our radius, and we substitute all of our beautiful values. All right, everybody has this one? Yeah. A ver. Let's go ahead and now move on into the next format. This format is called general form. It's called general form because it's been all multiplied out, distributed. There's no more parentheses. So all my beautiful terms have been nicely written out. However, we have to identify what the center and the radius is from the given equation. When we have x squared plus y squared plus 8x minus 2y minus 64 equals 0. So how do we do that? Well, I told you guys that we had to use a specific method that is called completing the square. And this method, I told you guys, or I gave you guys little squares on the sides, so we can go ahead and use and write out what those sides are so we can complete the square. So how do we use these squares? Let me go ahead and show you guys or remind you. Remember that we had the little parts, the partitions of the squares? Lo partimos. A ver, my first beautiful square is going to be for my x variables, and the second one is going to be for my y's. So I asked you guys to rewrite your equation so your x's are with your x's, your y's are with your y's. Okay, so my first term that I'm going to have is x squared. Do we have another term with an x? Which one is it? 8x. So we're going to write 8x. And then purposely, we're going to go and include an open space. Now, next is going to now be my y variables. So it's y squared. We have another one, which is negative 2y. And then purposely, we're going to go ahead and include a second open space. That beautiful constant, I told you guys to write it to the opposite side. What is a constant? It is a number. So I told you guys that we need to move it to the opposite side of the equal sign. So what do? We just do the opposite sign. So it's a minus 64. So we add 64. It moves on to my now right side of the equation. So we have equals. We have 64. And remember I told you guys that because we added this open space, we're going to be adding this little value that's going to come from my box. We have to also include it on the opposite side of my equation because whatever I add to one side, I have to add to the other. So let's see. This is a plus. So let's start with my first square. My first square are going to be with my x variables. So my first box right here, the small one, is always x squared. That one doesn't change. That one stays the same. So what are the dimensions of this box? We said that we had to multiply x by x to get to x squared. Now, the two rectangles that I have here, this one and this one, the area of these two rectangles represents the area of this middle term, 8. And they have exactly the same area. So I told you guys that we have to split it up into two equal beautiful rectangles. So how do we split 8x into two equal parts? It's now going to be 4x. So this is 4x, 4x. So we already have this side multiplying by x. We need the positive 4, positive 4. So it's called completing the square because we have to complete this last little piece. So how do we complete that one? What is the area of this little box? 16, we need to multiply 4 by 4, which is 16. So that's what we're going to add to both sides, 16. That's why it's called completing the square. A ver, let's see, numero, or the second part for the y's now. Again, my first little box will always be y squared. It's not going to change. It can't. It has to always be that variable with a coefficient of 1 raised to the power 2. A ver, what are the dimensions? Y and y. So therefore, how do we get to the two beautiful rectangles? This rectangle and this rectangle, they have exactly the same area and it has to have the sum of this middle term. So if it's negative 2, we have to split it up into two equal parts. So it has to be negative 1 and negative 1. So negative y, negative y. So we already have the y. All we need to do is multiply by negative 1 so it can become a negative y. Now we're going to complete the square. How do we get to that last little piece? Well, not little piece, but last piece. We're going to multiply negative 1 by negative 1, which is positive 1. A ver, from here it looks kind of confusing, but we're gonna go ahead and rewrite it. So it has everything. This square has the sides of x plus 4 times x plus 4. Instead of writing it twice, I'm going to write it down only once and raise it to a power of 2 because I'm multiplying the same beautiful part. Plus, what are the sides to this beautiful square? Well, it's y minus 1 times y minus 1. Instead of writing it twice, I'm going to write it down only once, and I'm going to raise it to the power of 2. And then my right side, let's go ahead and add everything together. 64 plus 16 plus 1. There you go, 81. Beautiful, 81. Now does it look more familiar? Yes. So I'm going to go ahead and write my standard form. Minus h squared y minus k squared equals r squared. So help me identify my center. What's my center? Negative h equals 4. So we're going to take the opposite value of that beautiful 4, which is negative 4. Negative k equals negative 1. So therefore, the opposite value of negative 1 is what? Positive 1. And my r squared equals 81. So all I have to do is take the square root. R equals, what's the square root of 81? Beautiful. Como que 8? 9. There you go. 9. So my radius has to be 9. My center has to be at negative 4, positive 1. Woo. Again, use your squares, use your parts, your rectangles. We're going to be using this method again next semester. It's not going to go away. We're going to recall. Okay, everybody has this? Okay, I'm going clear. All right, from here we moved on to our beautiful last part that we did, guys, our volume of our beautiful figures. We did three-dimensional figures. We started with prisms and cylinders. Here is a volume of a cylinder, given that the volume, find the volume if the height is 10 centimeters and the radius is 3 centimeters. I know the image shows 3 inches, but imagine that it's centimeters, okay? So my height is given from the tippy top of this beautiful cylinder all the way down to the beautiful center of the bottom part of the cylinder, which is 10 centimeters. How do we find the volume of a cylinder? We're going to find the area of the bottom part or the top part, our cylinder, our circle. And we're going to multiply that by its height. So we have pi r squared, which is the area of the base, multiplied by its beautiful height. So we need two things. We need the radius and we need the height. So what is our radius that's given? 3 centimeters, and our height is 10. So let's go ahead and substitute our values. We have pi. Pi is, I'm going to write 3.14 already. My radius is 3 and it's being squared. And I have to multiply this by its height. So 3.14. This is 3 squared is 9. And then we're going to multiply this by 10. This is now 90. And then all we have to do is multiply this by our beautiful pi value. Let me grab my calculator. It's not that bad. Have it. Let's see. 3.14. Multiply this by now 90. We have 282. Point beautiful 6. I know the value is not on your options. However, what happened in this example is that they use, instead of using 3.14 as pi, they use just 3. So they multiplied 3 times 9 times your beautiful height. So this is where you guys got the 200 and beautiful 70 centimeters cubed. So it is C. However, I'm going to have them, in your test, it's going to be exactly the value. So we're going to use 3.14 and I'll make sure it's specified. Okay. So the closest one is, yeah, 270, but it's actually 282. And these are centimeters cubed. Yeah. All right. We're almost done, guys. Woo! A ver, let's go now find the volume of this beautiful prism. How do we find the volume of the prism? We're going to go ahead and find the volume by multiplying or finding the area of your base and multiplying it by the height. So how do we find the area of the base? Here's the length, here's the width, and here's my beautiful height. We're going to go and multiply all of those dimensions together. So the area of the base, we have to multiply our length and our width. So we have 7.1. And we multiply by my width, 3.4. And our beautiful height in this case is 5.2. So again, find the area of your base, length times width, and then we multiply it by the beautiful height. Area of my base multiplied by the height. A ver, using our beautiful handy dandy calculator, because obviously we're gonna go and multiply this. It's gonna take us forever in a day. 3.4 times 5.2. In this case, we get my volume equals to 125.52 and some change. So I think it rounds to the nearest 10th. So in this case, it's going to stay as 125.5. And these are meters cube, or cubic meters.
1 square mile, so we can.
Okay, yeah.
2 square.
From here, we went on to now cones. In the cones, we found the following part. We found a relationship. We said that the volume of a cylinder was how much of a cone? 1/3, right? So we have, again, the same volume formula, pi r squared times your height. And all we had to do is just what? Add the 1/3 to it. We're going to multiply by 1/3, which is the same thing as dividing by 3. Okay, so we need 2 items. We need a radius and we need a height. So this one says the styrofoam model of volcano is in the shape of a cone. The model has a circular base with a diameter of 48 centimeters and a height of 12 centimeters. We're going to go and find the volume of a foam in the model to the nearest 100th if necessary. So let me go ahead and draw this so you guys can see it. So here's my circular base. Woo. Here's my beautiful cone. And let's go ahead and write down what information is given. What information do we have? It is a model. The model has a circular base with a diameter of what? 48 centimeters. So my diameter is 48. So what did I say we need? We need the radius. So we need a radius. Our diameter is 48. So my radius has to be 24, half of that, 24. Okay. And we're given more information. We're given that the height is, how much is the height? It is 12 centimeters. So this is my beautiful height, 12 centimeters. Okay, so let's go ahead and substitute our values. 1/3. Instead of pi, I'm going to use 3.14. My radius, we said it was 24, and it has to be squared. And my height says that it's 12. So let's go ahead and figure this out. Let's multiply all of my values together. Yeah, you multiply the 1/3 at the end. Or you can, it's either multiply by 1/3 or you divide by 3. You're doing the same action, the same mathematical action. All right, 24 squared. We get 576. So we have 1/3 times 3.14, 576 times 12. Let's go ahead and now multiply our beautiful radius squared times our height times 12. That gives me 6,912. And then we're going to multiply all of this by now pi, 3.14. And then at the end, we're going to multiply by 1/3 or divide by 3. Same idea. Not both, either or. Multiply this by 314. There you go. We get 27,703. So 1/3 of, remember that this is the volume of the cylinder. We're not interested in the volume of the cylinder. We're interested in the volume of the beautiful cone. So we have to divide this beautiful value by 3. Divide by 3. So therefore my volume has to be, or is 7,234.56. And these are centimeters, cubic centimeters. Woohoo.
For what? Actually,
A ver. So those were cylinders. We have 2 more left. Everybody has this. Almost like.
when,
Okay.
when, why?
Yeah. Okay. Perfect. All right. So let's go ahead and move on now to the second to last question. This one says Mike has a large plastic cup that he's going to fill with water. The plastic cup is in a shape of a cone as shown, which is the closest to the volume of Mike's cup. So if he has a cone as a cup here, let's go ahead and find the volume of this particular beautiful figure. So what is the volume formula? We said that it was pi r squared multiplied by the height. What's missing? We have a cone.
Wait, what was the word above? What was the word above?
Above cone.
Or what was the previous model word?
It's a cone.
What was it?
This one.
Yeah.
The previous one to this one?
No.
There was a cone. This is another cone. So it's 2 cones. Go ahead, Jamie. So what was missing? We have volume equals pi r squared times your height. We have a cone. So how many? There you go. We're missing the 1/3. We have 1/3 of the volume of the cylinder. For this one, we need our radius and we need our beautiful height. So what is our radius? 3, and my height is 7. So let's go ahead and plug in our beautiful values. We have 1/3, 3.14. Radius is 3 squared times 7. A ver, what is 3 squared? 9. 9 times 7 is? Woohoo! All right, let's go ahead and rewrite everything. It takes me longer to write everything down. 3.14.
Oh.
This is 63. And now from here, we can go and use our handy dandy calculator to help you find the rest of the parts. So let's go ahead and multiply 63 times 3.14. It is 20.06, 1/3. I don't think I wrote it correctly. Oh, I divided. Woo, 63 multiplied by 3.14. Ahora sí, more like it. We're gonna go and multiply this by the volume of the cylinder. We have a cylinder right now. We're gonna go and now find the volume of the cone. Remember that it was 1/3 of this beautiful value. So we divide by 3. So therefore it has to be 65.94. I think it runs to the nearest whole number. So it has to be 66.
Wait, does this sound like the last one?
Second to last. We have one more. The last topic that we went over was our beautiful Christmas ornaments.
Wait, but is it the same as 18?
Number 18, this one's the same as 18.
And
18 and 19 are very similar. The other one just had a diameter, and this one has a radius. So you can be ready for both. A ver, last one. Listos. Barney. Did you guys ever watch Barney?
Yeah.
I was obsessed with Barney when I was little. My birthday party was of Barney. And I was 4 years old.
fine.
Oh my gosh.
Oh, yeah.
He's your imaginary friend.
Really?
A ver. Barney, I'll show you guys right now after this what Barney was. All right, Barney wanted to know how much ice cream he got in one scoop. The radius of a scoop is 2 inches. We're gonna go ahead and find the volume by using our pi as 3.14. If you think about it, this is a very, very big scoop of ice cream. This is 2 inches, and then probably got a cup. I don't know. Let's go and figure it out. Pero if you guys remember, we had a beautiful sphere, a scoop of an ice cream that is very similar to a sphere. So we are going to have not a circle, but a 3D shape that looks like a ball. Here it is, a scoop of ice cream. Now we're given some information. We're given that our scoop of ice cream has a radius of beautiful what? 2. Yeah, 2. What is the formula to the volume of a sphere? It's 4/3. 4/3 pi r cubed. Remember that we don't have a height anymore. The height is repeated. It's twice the radius. So that's why we have that beautiful value. So we have basically 2 of the cones in here. So all we need in this case is we don't need a height anymore. All we need is a radius. So my radius is 2. So let's go ahead and plug in our value. 4/3 times 3.14. And we're going to have 2 to the power of 3. 4/3. 3.14. What is 2 to the power of 3? That means that we're multiplying 2 by itself 3 times. 2 times 2 times 2. It is 8. And then from there, we can go and use our handy dandy calculator. What is 8 times 3 and 3.14? That is 25.12. So 4/3 times 25.12. This right here, how do we multiply the fraction? We are going to go ahead and either multiply by your numerator. Remember I told you, multiply by 4. And then divide by 3. Multiply by the numerator and then divide by the denominator. So my volume is 33.49 and some change. It's round to the nearest 10. So therefore volume equals to 33.5. And these are inches, they're cubic inches. Woohoo! And we're done. A estudiar. Use your notes. We did lessons number, I think it was 22 through 32. There's only 10 lessons and all this information was taught in 10 lessons. I'm going to do it on Monday or Tuesday. Most likely Tuesday.
For the days out.
No, we didn't. Oh, no. It's on Wayground. I mean, on Wayground. It's on campus. It's posted on campus.